First, we will explain how the web server and API server interacts each other. We are using Axios to send API request and Express. In this case, we take as an example the register process. The user try to register, so the register AGS file will be opened and the register page will be shown to the user. Then the user send a post request with the credential, and the credential will be checked, in this case email, password and user identifier. If there are any errors with the format of the email, in this case we use the library validator to check them, we collect a series of errors. In this case the password should be with at least one special symbol, for example. After checking the body of the request, in this case is a post, so we collect this important information in the body. We will render the page again, but with all the errors. Then another middleware will be triggered and will encrypt the data. In this case, this endpoint is used only by the web server, so we are not using the HMAC signature in this case. So to do so, we encrypt the data with AES-256 by using the secret key of the server, and we store and send this information safely. Then the API will decrypt the informations, because the registered endpoint can be accessed only by the web server. We need to check if the AP key corresponds to the same AP key of the server. So in this case, if it's a valid AP key, we will take the data and decrypt it, and we will add the data again in the body of the request. After the middleware, the API server will respond to the web server with message with status 200. That means that the user is registered successfully, and we have a series of errors that, if for example the email is already registered in the server, it will send it to the web server, and the error will be displayed to the user. If the registration process goes well, a new salted hash of the password will be stored with bcrypt in the database. Then a login page will be prompted to the user, and if the login will be successful by using the right email and password, it uses again bcrypt to compare the password with the hashed password stored in the database. If it's successful, the user will be prompted to the dashboard page, and a session will be opened for the user by using his ID. In this case, we use the user data. The user data includes the image and profile name, the user ID, all the informations that we need to store in the user, and because we need to render them in every page. And in the dashboard page, we will generate an image randomly by using Gravatar if the image is new, or we will just use the image ID to take the image from the file system. In order to avoid reply attacks and validate the communication between the two servers, and to authorize the communication with the servers, but also for crypt and decrypt the data in case we are sending private data that needs additional level of security. We use a pair of keys, the API key and the secret key, and they are generated by the crypto library by generating a random bytes, in this case 32 bytes, and they are stored as an hexadecimal that will be then converted again in bytes. In this case, we store it in environment variables, as we did for the database that we will use by using the MySQL library, and they will be stored in the .env file in the web server, and when we update them, the server will restart automatically because of the configuration. To access the dashboard, the user should be registered and logged to the website, but for the tracks, every user can access it, and also developers. A query is sent with the data to filter the tracks in the database. In order to validate the communication between the web server and the API, we need to use the secret key to generate a hash with crypto that will be used to validate the communication. In this case, we are also adding a timestamp to check if the request was made in a valid time frame to avoid reply requests. So after receiving the signature and the query, the database will activate. The API server will check if the request is valid by using HMAC authentication. So this middleware will be called, and it will check if there are mandatory parameters like the API key, the timestamp, the signature, and if the timestamp is in a valid time frame. Then it will check if the API key is the one used from the web server, or if it's used, or if it's a developer, for example, that needs to access the data in the database. So we check if the API key exists in the database. Then we use the secret key again to generate the same hash with the message, and we check if it's valid or not. If the signature is valid, the API will respond with the data. In this case, we'll collect the query parameters, and they will be used with a query in the database to generate the tracks, the list of tracks filtered in this case. If the data is missing, there are some default values that will be added in order to show all the tracks in the database. The limit is 500 for each request. In order to limit the number of requests by developers, we use a different weight for every different endpoint, and we use a middleware that will limit the number of requests. So we will set a maximum weight, a weight for the ban, and an interval when the weight will be resetted, in this case 1 minute. Every minute the weight will be resetted for all the IP. The IP will be banned from the service if the user continue to spam with too many requests. A retry after is returned, telling the user how much time should wait before getting back in the service. So in this case, we need to restart the server, and we are getting an error that tells us that the API key is missing, because we need the API key and also the signature with the timestamp in order to access the website. Then we get the two-mail request error with a retry after that tells us how much time we need to wait in order to not get banned from the service. But if we ignore the retry after, we eventually get banned from the service, and it tells us how much time we need to wait before we use the service again. If we try to access the service, we receive a message telling us that we are banned. Every user can access all the tracks in the database, even if they are not registered. So we have in total in our database 50 tracks, and some of them the data is missing, obviously. But for example, here we can see that there is the release date, and here is not included. So for example, if we want to filter all the rock tracks, in this case we get less result. The total items in the database is 50 items. Or we can, for example, find all the tracks that have included a letter A in the name and that are also hyperpop. So in this case we can see all the tracks from Deco. But we can also type the name of the artist, and we can get all the tracks from Deco, that are 7 in total. And we can filter any tracks with any parameters, even if they are combined together. The web page is also responsive to allow user to use it in a mobile phone. And if we for example go to the specific track, we can get, for example, the track called Crux. We can see that there is also a review, because we have 2 users in this database and they reviewed the same tracks. So if, for example, we change the review of one of the users, the average will change, and if we refresh the page again, we can see that now the review is only 3 stars. That is the middle point between 1 and 5. We can also copy-paste the URL of the web page with the query included with the filtering, and we can show, for example, to our friends the same results by just copy-pasting the URL. Now we can go and try to log in the dashboard. As we can see, now we can try to log in with 2 different accounts. One account is already logged in the dashboard. The second one is still logging in the dashboard. As we can see, we get an access denied error that tells us that we need first to log in before access the dashboard. So we try to log in, and now we are in the dashboard with 2 different accounts. As we can see here, the user image is taken directly from the file system as the track images, and in the case of the user Alicia, we don't have any images, so we have just a random generated image. We can also log out from the system, and logged out page will be displayed and ask if we want to log in or return back to the tracks. Now we can show all the error messages that the user will get in order to avoid the user to make the same errors every time. If we try to register here, we get an error because the email is already registered and we can see it from the database. Then we can try to register a different email, but in this case the identifier is not available, so we need to choose a different identifier. Then we try to log in with all the data correct, but a wrong password. So in this case, we just used the lowercase letters, and in this other case here, the at the beginning of the identifier is missing, and also the password is incorrect. So we get two error messages, one for the password and one for the identifier. And then we can try to just register without any data, and we get also an error. So if we try now to change the email and put a strong password with all the required characters and different identifier and try to register, we get register as successful, and we can go to login. We can check from the database that a new user is added with the hashed password and the timestamp of the creation of the account.